All right, well, let's look at some answers here. It's your last chance to practice and ask questions, so please do. What can I help you with? Did we agree? Did we get all the same answer? I don't think we did. We disagree on 2. I think we disagree on 3. So check it out. Let me know if you have any questions or... Before you do any of this, you need to get your x's together. If you have an x on the left side and you have an x on the right side, you have to combine those before you do any other steps of solving or anything like that. Sophia, did you have a question? No? Okay. Please check your answers. This is your best way to address any misconceptions you have or any careless errors you might have made, something like that. And we disagree here, right? So you need to really check and you need to ask. If something's not making sense. Sydney, of course. We agree on everything? I don't think so. I got -2 for number 3.
How did you get?
You got 2.
You don't care if you just like list it over here, like just from left to right.
Nope, not at all.
Because
That's
Web-
basically what I did.
Because WebAssign like makes you do it like a
In order. Yeah.
list of rows.
It doesn't make any difference to me, really. Yeah.
No, I think maybe it's 2.
Looks like we agree, yeah. All right. Man, you guys are being so quiet. Can you imagine? I don't know. Imagine if you went to a doctor and the doctor was like poking and prodding and checking and doing all the things that doctors do, right? And then, later on you found out that you had like cancer or something. And you later on found out that the doctor, based on all their poking and prodding, thought that maybe, they thought you probably did have cancer, but they just didn't say anything. Would that just, wouldn't you be, unbelievably upset with the doctor? Why didn't you, ask me about other symptoms, right? You guys need to be not like that doctor. I'm walking around and, peeking over shoulders, and I'm seeing, oh, man, we, totally disagree on number 2. And yet, what's going on? No questions, no talk, just, I'm good. Isn't that crazy? I don't know, that to me just, does not compute. You want to know who's made more mistakes than all of you guys combined, probably? This guy. This guy right here. I'm not ashamed to admit it. I'm really, really good at math, but I've made a lot of mistakes. Just like you. I'm not ashamed to admit it. Don't be ashamed to admit that you don't know something. That's why you're here. I'd love to help. Did you guys know that no one in this class has a 100% average? Not even close. Not even close. There's some A's and stuff. That's great. But nobody even close to 100%. Everyone's made mistakes. Everyone's had a moment where they think to themselves, ooh, I don't get that. I was expecting to do better, and I didn't. But come on. What else can I do? Come on. Did you nail them all? Did you get them all perfect? What did you do wrong on that one?
I didn't put the addition sign.
So let's talk about that. Did anybody, and you can, I don't know, you can say you did or not, did anyone else make a little oops right there, that green highlighting? Do you see it right here? I'm making it a darker. Did anybody leave that as a -4 by any chance? Yeah. See, there's 3 or 4 of us at least. You forgot to distribute that minus sign all the way across. This is something worth talking about. Maybe, and this is actually the one that was just mentioned right here, this one, right? So that negative get distributed over there to get you a +8, or did you leave it a -8, right? So there's all kinds of little details I'd love to try to answer for you. But the truth is, I can't grab your mouth and move it and say, yes, Mr. Anderson, I have a question on number 4. That just doesn't work, right? I guess I could try that, but that'd be very weird.
And then you would do
Okay,
2x.
so we're ready to move on? Is that right? All right, let's do it. You will be quizzed on this here in, I don't know, 30, 35 minutes, something like that. Okay, so here we go. We are going to try to put some stuff together today, here in the first part of our class. So we're going to do some graphing again. This will be our last major push on graphing. We've been doing this all week. And so I want you guys to move forward to practice number 1. It says graph, and it gives you this 5x minus 2y is greater than negative 4. So for those that might be feeling like, I'm not sure exactly where to start, I'm going to give you a hint. The place that I would start here is, I would solve for y. I would try to take that inequality and I would try to get the y all by itself before I did anything else. So I'll give you some of that direction there. You give it a shot.
So 4
We'll check that in a minute, and then we'll try to get your graph on there as well.
negative equals 4.
Hey, can I help you with this?
No, I got it.
Shading and dotted solid routine. So let's take a look here at number 2. So this is something we just did the other day. Let's review this really quick. If you have this lovely equation or inequality like this one, and the only variable is an x, before you do any math at all, you know exactly what the line would look like. The only variable is an x. What does it look like? If you tried to ski it, you'd get x'd out, right? You get it? X'd out. If you tried to ski it, why would I ski that? Boring, right? Not worth my time. Why would I ski it? I'd get x'd out. Or like the one we just did, it's got an x and a y, might be fun. Got it? X'd out. Why would I ski it? X and y, fun. Okay. So please take a minute, see if you can graph this. It is an inequality, so we've got to consider the dotted, the solid, the shading, that kind of thing. So please, get busy. If you know this is going to be a vertical line, right, you get x'd out. See if you can put that vertical line in the right location. Where would this be? It's only got an x, so it has to be vertical. It only has an x, so it must be vertical. Sir. So that's a point, right? Like literally that's a location. I disagree with that because the way you've written that is your x coordinate is 0. Correct? X has to be negative 1. X has to be negative 1. There are absolutely no constraints on y. Y can be whatever it wants, right? But the x has to be negative 1. You see that vertical pattern showing up, right? Look at this picture. No, you're supposed to have a drill. False alarm. Hi, Sophia. Great question. I would say you do a test out, right? So basically a question of left or right. And I think 0, 0 is still, in this case, a likely thing to try. So if you plug into 0, 0, there's only an input for an x, right? No. So what you're doing is when you test out, you're literally taking the point and plugging it in to create x and y. So 0, 0. What I'm going to do is I'm going to plug in 0 x. 0 is less than negative. So, and then what you do is, if you look at that and ask yourself the all-important question, is that true? Is 0 less than negative 1? It's not. So what that means then is that your test point is not in your answer region. And so since there are only 2 answer regions, let's do the other one. And so yeah, that shading makes sense. It actually should be a solid line because you've got the 4 equals. So major bonus points. So what's that? Not equal to? Correct. All right. So vertical. As we decided, this is a vertical line. where would this vertical line be located? -1, yes, over there at the -1 location. So this would look something like that. It's pretty much vertical. Now, should I be leaving this line solid as I currently have it, or should I go back and erase some and make it a dashed line? Why solid, Bree?
Because it's less than or equal to.
And it's the or equal to part, right?
Yeah.
That's the important part, meaning we got to leave this a solid line. Leave this a solid line. And then the final question is, now that we've decided the dotted solid, is we need to decide shading. How do we decide shading? What did we do last time? What do we do with 0, 0? Plug it in and just see what happens, right? So I am going to check 0, 0. That will work here. The thing that's different about this one is that there's no input for y, is there? But there is an input for x, so check this out. If I'm going to be plugging in 0, 0, I would write 0 is less than or equal to -1. Then you have to decide, is that true or is that false? Is 0 truly less than or equal to -1? It's totally false, right? And so that point that I tested out was right here, and that proved to be false, didn't it? And so that means that 0, 0 is not a part of my answer region. See if you can follow this logic. Since 0, 0 is not a part of my answer region, and there's only 2 possible regions, doesn't that mean that it has to be the other one? So I would just come over here to the left side of my vertical line, and I would shade over there on the left side. And what that means then, of course, is that if you pick out any point on the left-hand side, it should make that inequality true. If you picked out any point on the right side of the vertical line, it should prove to be false. Okay, let's do the last one there, I think, in this little set. So if you flip over to number 3, why don't you try this one? Number 3. This one says y is greater than 2. So please remember, x and y. Mason, x and y. It might be fun to ski. Only x, I'd get x'd out. Only y, why would I ski that? Boring, no fun. Okay? So please try number 3. Have you decided about shading yet, Noah?
No.
Why don't you do some testing out and decide, where do we shade? Who knew you were going to come to art class? Some quality shading going on over here. All right. So again, this will be my last chance today to reinforce this perhaps. Whenever you're approaching a linear equation or linear inequality, and the only variable you see is a y, without doing any work at all, we should automatically be able to know that the line is going to look like what? It's going to be horizontal. So if in the end, if you look at number 3 and your line is anything but horizontal, we need to go back and do some rethinking. Where would this horizontal line be located? At 2, at y equals 2. So here is my attempt to do that. Look okay?
Yeah.
Oh, yeah. It looked okay to me, see? But now, y'all can see that. Okay, there we go.
No.
It's right there. Let's talk about that. Sebastian seems to think it should be dotted. Why on earth would this be a dotted line? Because what?
It has like the line
if that means equal to, then that's the only time it's solid.
And that's not there, is it?
No.
So we're dotted. Perfect. Great explanation. Okay, so here is my dotted line. The final thing I got to decide is shading. So I'll come over here and try to make a decision about shading. How do we often test shading? Plug in, not 0, but 0, 0, right? So we're going to check 0, 0. But it kind of makes sense what you said, Noah, because isn't there only one input?
Yeah.
The only input is y, so we can only really input that. So we get 0 is greater than 2. Is 0 greater than 2? It's totally false. That's right. So 0, 0 is right there. And since 0 is not greater than 2, that means that 0, 0 is not part of my answer region. And how many regions are there for us to even pick from? So if it's not the one down below, it must be the one above. That's right. So you guys are catching on really well. So we shade up here. So all of those points in that shaded region should prove to be true in our inequality. Any points below should prove to be false in our inequality. Guys, how are we doing? Let's see here. Would you all, I think I know the answer to this. Do you feel like, remember the very first one we did? Remember the very first one we did where we had to solve for y and then graph?
Yeah.
I feel like you need one more of those, don't you? So if you would, flip over to 4. I think you'll find one more there. Yeah. So this is very similar to the one we did earlier. You're going to have to solve for y and then graph. This will be a nice way to maybe kind of a final little capstone on our graphing experience. If you can do this one, I think you're in a pretty decent place. So please try number 4. You guys start to make some decisions about solid and dotted and shading. Maybe start to peek at your neighbor's paper and share yours with your neighbor and show them and ask, did you get the same thing as me? Wow, look, we did. Oh, wait, I had solid, you had dotted. What's the deal? Right? So you talking those things over, you can learn so much from each other, processes of thinking.
Draw the line.
Oh, this is yours, actually. She's like, I like that paper. I think that's a pretty good score. I can go with that one. I like your theme, Sasha. Okay, seeing some pretty nice lines. Have you guys been checking with each other? Make sure you decide about solid dotted shading. It is okay. It is dotted.
Yeah,
Okay.
it's just really big line.
I believe you. You're a very precise person. And now that I'm closer, you guys need to talk about shading. In fact, all 4 of you are about in the same place. You guys need to be thinking about shading. Mm-hmm.
I heard that.
Mm-hmm. Are you all done?
Yep.
Okay, we'll check your answer here in a second.
All right.
So maybe those that are maybe checking or whatever, I've got the slope intercept form up there. I'm seeing a lot of good papers. Yep. You got the right slope intercept. Oh wait, no, hold on. It should be u divided by a negative. Your inequality needs to flip.
Oh yeah.
That might affect your shading. I don't know. Double check. When you did your test values, did you guys test in the original? Like the original printed?
Original.
Did you test out in this?
Oh no.
Or did you test out in that?
No. I did this.
Okay, so at least I wouldn't go and erase your shading because I think your shading might be right. We might want to check your analysis. Did you flip your inequality around when you divided by negative, Sophia?
I flipped it, but I didn't flip it back.
You shouldn't flip it back. No,
It's right. This is right. The shading is right.
I think the shading is right, but this
But I did
was
flip
wrong.
it once I did.
This should be y is greater than. So, yeah, so Sophia, what we were talking about earlier is, I'll write it up on the screen. This inequality right here and this inequality right here, they are the same. They're exactly the same relationship. They're just different forms. And so you could test out on either one. Once you flip the inequality in that second form, it needs to stay flipped. We don't go back later on and change it. Yeah.
Sure.
All right. So when you graph this, did y'all get a y-intercept of 0, 6? So my y-intercept would be right about there.
Yeah, thank you.
And then my slope, hey guys, could you quiet down, please? My slope would be up to right 3. So I'm getting this. And then my line, I think, is going to look about like this. Are you guys seeing the same thing I am?
Yes.
Then when you decide on the dotted or solid, did you guys all land on dotted for this one?
Yes. Yes.
That's exactly right. Why on earth would we make this a dotted line?
There's not equal to.
There's not an or equal to is the right answer. So it's dotted. The final thing we got to do is decide shading. Noah, how did you decide shading again?
Plugged in 0, 0.
Yes, you test out 0, 0. I had to wait a second here if he was going to say the other 0, and he did. He did. Okay, so we're testing out 0, 0. Are you guys, hey, listen, please. Are you guys in the habit of testing out in this green highlighted inequality or the yellow? Does it matter whether you use green or yellow? It doesn't matter at all. They're the same relationship. So if you test out in green and you test out in yellow and you get something different, that's a problem, right? They should agree. Should agree for sure. I'll test out in yellow this time. So with yellow, I would get 0 is greater than 2/3 times 0 plus 6. 0 is greater than 0 plus 6. 0 is greater than 6. Is that true? No. It's totally wrong. So doesn't that mean that 0, 0 is not in my answer region? Yes. So what must that mean then? It's got to be the other one. Yeah. So instead of lower right, it's going to be upper left. So I would shade up in there. It has some serious style, doesn't it? Yes, I agree. Okay. We're going to leave these kind of graphing things alone for the moment. So do you have any questions? Okay, fair enough. So guys, again, I want to break this up a little bit for you. So I don't want to just march on into something new. Let's go ahead and do our DMR quiz right now. Okay, so clear off your desks of everything. What does slope mean? What'd you write down? Mason.
I said that it was the way that x point is related to the y point on the graph.
The way that an x point, so when you say x point and y point, are you saying how this relates to that?
Like yeah.
I would say that you're kind of close, but I would disagree. I would say this. I would say that it's how, I'll call this point number 1 relates to point number 2.
That's what
Yeah, but it's not how the x-coordinate relates with the y-coordinate.
isn't the x coordinate 0.1?
No. X, y, the whole x comma y. So like if I said, think about it like this. If I gave you, I'll erase this in a second, so please don't write this down. If I gave you an x and a y axis, and I said, plot the point, and then I just said 7. What does that mean? Nothing. You're right, it means nothing. What would I need to go along with that 7 to be able to actually plot it? I don't even know which one that is, do I? I'd need like 1 comma 7 or 7 comma negative 3. Now I can plot that. So I would say that when we talk about a point on some kind of graph, I don't think we could say that the x-coordinate is the point. I don't think that we can say the y-coordinate is the point. The whole x comma y would be the point. So I would say what you said is pretty good. Like in the end, your sense of it was slope is how one point relates to the other one. It was very insightful, actually. I think that's a pretty good place to start. Did anybody write anything else down? What does slope mean? He says he has a big brain. So everybody wrote down the same thing as Mason, or you wrote down nothing? Come on, share. I want to hear. Bree.
I don't know if it's right, but the angle of a line.
Yeah, the angle of the line. Was anybody else thinking that? It's a fair description, isn't it? Like, this line has a certain slope, and this line has a different slope because the angles happen to be different, right? Bray, what do you think?
What is it? An angle on a graph?
Angle on a graph, sure. Angle on a graph. Slope definitely has the sense of we're addressing some kind of an angular feature. Agreed. What do you think, Ella?
Except that it was like the m in the equation.
Okay, so m in y equals mx plus b. I think we can all agree on that, right? For sure. It's how those things relate together. 100% correct, yes.
The amount of change over set points.
Ooh, okay, so let me write this down. Amount of change over set points. I think we could like kind of flesh that out a little bit and make it really, really good, but that's pretty good. I think I get your sense of that. You're like, something's changing between some points, and slope helps you describe that, right?
It's not like change, it's a different word.
I think change is a good, I think there's a fancier word for it, but I think change is a good word. I really do. Did anybody think of this?
Oh, I did that.
We used that, didn't we use that when we graphed lines?
Yeah.
Let's say slope, rise over run. So I'm gonna start going where Julia was going a little bit, and I'm gonna build this out. See if this makes sense. If at any point it feels like I've gone off the rails a little bit, you let me know. Would you guys be okay if I described the rise as the change in y?
Yes.
Rise would be how much the y coordinate changed.
Yeah.
Like if I sit down, I'm not very tall. But if I rise, doesn't my y-coordinate on the top of my head change? It's that amount of change that describes the rise, right? Change in y. So then, if rise is change in y, what's run? It's the change in x. Yeah, okay. So then we're getting it. So change in x. I'm going to throw, and Julia, this might be what you were referring to earlier. I'm going to throw in some fancy letters just in case maybe you've seen this before. Or maybe you like this better. I'm going to actually use some Greek letters, or a Greek letter. So the Greek letter is delta. It's a triangle. So this is the same thing as saying delta y over delta x. Have you guys ever heard of the airline Delta?
Yeah.
Do you want to know why they call themselves Delta?
Because
What does a plane do to you?
Makes you
Doesn't it change your location? No, listen. Doesn't it change your location?
Yeah.
They're delta-ing your location. I'm not kidding. That's why they named it what they did. The only reason you fly on an airline is to change location, right? Does anybody fly on the airplane for the food? Or how about the really cramped seats? Does anybody fly on the airline for the really cramped seats? Me neither. They seem to get tinier in time. Like, either I'm getting a lot bigger or the seats are getting a lot tinier. I think they're getting a lot tinier, right? They change your location. That's why it's called Delta. Seriously. Did you notice? Next time you look, notice how on their little logo it's sort of a triangle-y looking thing? Somebody was thinking, right? Somebody knew a little bit about math. Anyways. And then the place where I want you guys to land is this. How do you find the change in something? Let me give you an example. Back when you were younger, and maybe you're still, some of you are probably still going through this, but did you ever have one of those summers where like you entered the summer in like May and you were like this tall, and then when you left the summer in September you were like this tall? Right? You like grew 6-7 inches in like 4 months. Anybody else have that? I know I did. I was just like, I was kind of a short guy. I shot way up, and I was like a little taller than everybody else for a little while, and then everybody else caught up and passed me, right? How would you find the change in your height? Let's say that when you enter the summer, you were 5 feet tall, and at the end of the summer, please listen, this is so good. I hope you listen. You started the summer at 5 feet. You finished the summer at 5'6". How would you find your change in height? You would subtract, wouldn't you? 5'6" minus 5 feet. You grew 6 inches, right? Yeah. So here's how you find the change in y. It's subtraction. We're gonna term it like this. It's the second y minus the first y. Those are little subscripts. They're not exponents. So second y minus first y divided by, what would you guess the denominator is? No, these are not exponents. These are not squares. It's just saying second y or first y, right? So it would be second x minus first x. Has anyone ever seen that? Okay, so if you took some kind of an algebra class in middle school, I would sincerely hope that they showed you something like that at some point. So this right here, and I'll tag on what Ella said at the beginning a minute ago. These are all descriptions of slope. But I'm going to tell you right now, for us, the most useful is going to be that last one. We're going to say that slope is equal to the second y minus the first y over the second x minus the first x. Or sometimes we'll say y2 minus y1 over x2 minus x1. You want to know the biggest trap on this? The biggest challenge that people have is messing up and losing minus signs. That's the number one mistake people make. Maybe you can see a number 2 up there. That's very possible. Okay, so I wanted to show you one of these and how to do it, and then I'll have you guys try one on your own. So here goes. Number 1 says, find the slope, this thing we've been talking about. Find the slope of the line that passes through those 2 points. Step 1. We got to decide which one is the first point and which one is the second point, right? To me, it's very natural that the first one, we would call that the first point. And the second one, we'd call it the second point. So I'm going to label these up here. Would this make sense to you if I put, this is x1, comma, y1? So the 2 would be your x1, and the 5 would be your y1. Does that make sense? As we try to find slope here. And then, of course, the other one would be x2, comma, y2. So if I'm trying to find the slope between these two, what I'm going to do is I'm going to write this. And again, for a lot of you, this is brand new. So if it didn't make sense at first, wouldn't that be totally expected? So if I do something that doesn't make sense, you're going to tell me, right? My y2 would be 3. My y1 would be 5. And what do I do to find the change? What do I do to find change? I subtract. So it'd be 3 minus 5. And then down in the denominator, my x2 would be 7. My x1 would be 2. And what do I do to find the difference? I subtract. All right, so what's 3 minus 5? What's 7 minus 2? So my slope apparently is negative 2/5. It's the rate of change between my points. We want you guys to try number 2. Number 2 is tougher because you can see there's some negatives. But if you follow that pattern I gave you, I think you'll have a good chance for success. Okay, so y'all okay with this being my point number 1? Hopefully this just makes logical sense that the first one you see would be point number 1. And then the second one you see would be point number 2. So x2 comma y2 would go with that one. And once you get these things kind of lined up and labeled, then maybe we can get this done. So I'm going to say slope equals a fraction. What's my y2? Negative 6. What's my y1? Now, I want to be really super careful. I've done this in an order that I really am being intentional about. My y2 is negative 6. My y1 is 7. What do I do to find the change? I subtract. So it's going to be negative 6 minus 7. There's going to be a real trap waiting for you in the denominator if you're not ultra careful. I'm trying to direct you and help you be ultra careful. What is x2? What's x1? Negative 4. And how do we find the change? Subtract. Now this is where people end up losing minus signs. Isn't this really negative 6 minus 7 over negative 5 plus 4? That is exactly the step. I'll highlight it for you in blue here. That's the step where people, if they're going to lose a minus sign, that's where they lose it. It's because they go too fast and they get a little lazy or a little careless or something, and they lose a minus sign, and they end up getting the wrong answer over and over and over again. That's why I presented it as what's x2, what's x1, what do you do with them? You subtract. That should keep you straight, I hope. Okay, so then for a final answer here, did you guys get negative 13 over negative 1, also known as 13 over 1? Okay, so either one of those would be fine for your slope. How are we doing? Okay, good, bad? Julia, yes, no? Okay, cool. All right, so we're going to finish up with our next page. This will be the last thing we do for our week. So if you guys would flip ahead to practice 1. And I wanted to make sure we got to this. This will really help you with your WebAssign. Listen up, please. You guys have done really well. You guys have been very patient. Let's continue that patience through to the end. Okay, so it says, write the slope-intercept equation of the line that has a slope of negative 1/7 and a y-intercept of 0,6. So here's the deal. We spent this whole week taking equations of lines and graphing them, right? Now what we're going to start doing is taking information about a graph, like in number 1, and writing the equation of the line. And so to do this, I'm going to consistently use the same methodology. It's kind of like the one we worked on yesterday, Bray, that one that we were talking about. I am going to very consistently use my point slope format. Okay, so I want to remind you that. Point slope is y minus a y coordinate equals slope times x minus an x coordinate. The two things I need to have to write the equation of a line or draw the graph of a line is I need a slope and I need a point. So to me, having point slope form up there makes a lot of sense. Okay, so we've used this, I think, a couple of times already. We're going to use it a lot moving forward. Hopefully you'll get really good at this. What's the y coordinate of the point on my line? So 0 is actually the x, right? Because it goes x comma y. So it's 6, right? So I would write this as y minus 6 equals, what's my slope? Negative 1/7. I'm going to put that in place of the m. Parentheses, x minus, what's my x coordinate for my point on the line? It's 0. Okay?
Shouldn't it be 0, 0?
Nope, because the point is actually 0, 6.
So why is it x minus 0?
Because the x coordinate is 0. This is x, this is y. Say again, Mason?
If it's x minus x, wouldn't it just be 0 minus 0?
Nope, so it's x minus x1, and x1 stands for an x coordinate. You're right, if it was just x minus x would be 0. Completely agree. What that stands for, the little 1 makes a difference. So it's saying x minus your x coordinate. It'll be a number there. So this does say we need to get to slope-intercept form. So isn't slope-intercept form that one where the y is by itself? What do we need to do to get the y by itself?
Plus 6.
That's right. So if I add 6, I get y equals negative 1/7. What's x minus 0?
0.
No,
X.
it's just x. X minus 0. You take away 0 from something, don't you just get the something?
Yeah.
X minus 0 is just x plus 6. Oh my goodness, isn't that slope-intercept form? So pretty. So pretty. Okay. We'll practice that a lot more, but I thought I'd finish up with a slope exercise. So if you guys would, take a look at number 2. Take a look at number 2. And it says, find the slope of the line graphed below. We got just a couple minutes left. Let's make the most of them. Let's not be in the habit of wasting our time. We only have so many minutes on this earth, so many minutes in this class, so many minutes together. Let's make the most of it. Come on. You know, it would be really helpful for you to try this, Chase. Okay.
It's 2 over 6.
Your definition of rise over run might be really handy here. The rise over the run. Give you guys another minute or two here. We'll wrap it up here before we go. Any questions there, Oliver? No? Okay. We're looking at this. We're trying to decide what is the slope of that line. Okay. So guys, we only have about a minute and a half left, so I do need to stop. And maybe we can discuss an answer here. Hey guys, please don't pack up. We are going to finish this well, even if I got to wait for you. You've done really well. This is a longer class. You've done really well. Let's finish well, okay? So the first thing you got to do is you got to find some points that are actually on the line. And I don't know what you picked, but regardless of what you picked, would you guys agree with me that this point in purple, you see, is that actually on the line?
Yeah.
Okay. And then I just need to find one other point that is actually on the line. So if I were to pick this one, do you see how that point, we don't really know what the coordinates are?
Yeah.
So that's not going to really help. Do you see how this point right here, we don't know what the coordinates are there? I got to pick some point that I know. And would it be fair to say that that one right there, that appears to be right on the line? Okay. So I'll put a point right there. Here's where I like the idea of rise over run. Between those 2 points, what was the rise? How far did it go up?
1.
It went up 1, okay. Yeah, we're going to talk about that in a second.
Really?
It rose 1. How far did it run? Yeah. So let's see here. So here's my rise. Here's my run. And I agree. Guys, you're packing up, and I really wish you wouldn't. I'm going to wait. You have no idea how distracting that is to me, much less each other. Didn't you run 3? And this is where I would encourage you to think in the end about what this really looks like. From left to right, isn't it going downhill?
Yes.
Yeah.
So doesn't the slope have to be a negative number?
Yes.
So I think I'd close this off by saying it's got to be a negative 1/3, and that would be it. That would be our slope. We put a box around that, and we found the slope. We've just started this. We'll continue next week. Hope you have a great weekend.
Thank you.
See you later.